10 says, in how many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? Okay, the 4 I's do not come together. That's what the person is saying. How many of the distinct permutations of the letters in this? So permutations of Mississippi, let's write the word properly first. Write what are the like letters. Let's club them together. We have M, we have I, okay, we have S, S, then you have another I, then you have S, S, then you have I, and then you have P, P, and another I. So there are 4 I, 4 S, 2 P, and 1 M. Let's count. 4 plus 4 is 8, 9, 10, 11. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that we don't miss anything, right? How many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? Okay. So let's think of an alternative approach. If there are total number of permutations, there will be some arrangements in which the 4 I's come together, and there will be some other I's in which the 4 I's do not come together. Maybe 1 or 2 3 will come together. So we can easily find that case when the 4 I's are together, and we can find the total. So the difference will give us the answer of this one. Yes, yes, yes. That's what we are supposed to do. So total minus rejected is the approach that will follow over here. Total number of ways is arranging these 11 alphabets at 11 places. So what you'll have is 11 factorial over repetition. Repetition of I's. There are 4 similar I's, so we'll have to divide by 4. 4 similar S will have to divide by 4. 2 similar P's will have to divide by 2. Minus rejected, in which these 4 I will be clubbed together, right? They will act as one unit because they have to be kept together for the rejected cases, right? When the 4 I's come together, that case is rejected, right? So we'll have 1, 2, 3, 4, 5, 6, 7 and 1 bag. 8 things being arranged at 8 places. This is 8 factorial divided by these 4 and these 2 are alike letters. They will have to divide by these 2, right? The 4 I's that are present in the bag, their internal permutation will not have any impact, right? Their internal permutation will be 4 factorial, but they are all 4 alike, so we'll have to divide by 4 factorial again. So 4 factorial times 4 factorial, which is actually 1. Their internal permutation will be, right? The 4 I's come together and they are alike, therefore 1 for that. And this is the final answer that we are interested in. 11 factorial upon this minus this and this. So let's see, where does that take us? This number is 11. This number is huge, by the way, right? 11 factorial will be pretty huge. 8 factorial upon 4 factorial, 2 factorial can come out common, right? Let's bring that number common. We'll have 8 factorial over 4 factorial, 2 factorial coming out common. What will remain is 11, 10, 9. Okay, then you had 8 factorial is gone. 4 factorial, 2 factorial is gone, and this is 4 factorial, 4, 3, 2, 1 at the denominator. That's what we have, right? Minus, you have a 1 over here. Minus, you have a 1 over here, right? This is what you get. And using this, let's try to solve this one. 8 factorial is 8, 7, 5, 6 times 4 factorial. So this is 8, 7, 5, 6 over 4 factorial is 4 factorial and 4 factorial times 2. This goes, what is this? Let's multiply them together. Can we cancel some things? Yes, we can cancel some things. But we can also see that if you cancel a factor of 2, that will unnecessarily give us a 5. 10 multiplication with 10 is very simple, right? So this is 99 times 10 is 990. 990 minus 24 is what we are interested in. On taking the LCM, this is what you are interested in, right? Denominator is 24, if you observe that carefully. So can we handle that 24 as well? Yes. 8 times 6 is 48. 2 times 24 is also 48. Denominator goes, yes. And what you are remaining with, what remains is 7 times 5, which is 35 times this 990 minus 24. And what is that? That is 900, and this will be 66. Is it? Yes. 80, yes. This is 966 times 35, and you can take out a 2 from here, give this to here. This 35, this will become 70. And this will become 483, right? And now it becomes very easy to multiply. 70 times 483 is very easy to multiply. Let's check that number, 483, yes. So the final answer, number of ways, final. will be equal to 70 times 483. And what's that product? Let's multiply them together. That's pretty simple. There will be a 0 at the end. 7 times 3 is 21, 1, 2 carries, 7 times 8 is 56, 8, 5 gets carried, 7 times 4, 28, 33. 33810 is my answer for this question over here. That's the complete solution of this using total minus rejected idea. We have also used bag over here, right? Bag idea over here. What's the bag idea? What's the idea of bag? That we put all of those i's together, right? That's what we have done over here. And the idea of bag has also been discussed and used along with this question. That's the complete solution of this. Let me get a side so that you can take a look